So, hello students, in the previous class, we did up to question number 28. And I said in the next class, we will start with question number 29. So, I'll paste the next question. Question number 29. This is question number 29. As per the question, the function x cubed minus 6x squared plus 9x plus 8. The function is strictly decreasing in which interval? So first we have to take the function x cubed minus 6x squared plus 9x plus 8. Find the derivative of the function 3x squared minus 12x plus 9. Or 3 into x squared minus 4x plus 3. Set it equal to 0 and factorize it. X minus 3 into x minus 1 is 0. So x will be 3 or 1. Now take a number line, write 1, 3, and make from minus infinity to infinity intervals. So now you have to take in each interval a testing number. Like here 0, here 2, here 4. And you have to put it in the derivative, that is 3 into x minus 3 into x minus 1. If you put 0, this is positive, negative, negative. Total f prime will be, f dash will be positive. Then in the derivative, if you put 2, 3 is positive, 2 minus 3 negative, 2 minus 1 positive. So f dash will be negative. If you put 4, 3 is positive, 4 minus 3 is positive, 4 minus 1 is positive. So f dash is positive. Wherever f dash is positive, there f is increasing, negative decreasing, positive increasing. So the increasing intervals, you can see the function is increasing on the interval minus infinity to 1 and 3 to infinity. That is present in option D. So option D is correct. Next, we will go to question number 30. Here is question number 30. Again, the function x squared minus 2x is increasing in the interval. It is being asked. So take the function x squared minus 2x Find the derivative, that is 2x minus 2. Take 2 common, x minus 1, and make it equal to 0. So x equal to 1 is the turning point. On the number line, you have to write this turning point 1. Go from minus infinity to infinity by making intervals. Now in each interval, you have to take a testing number, here 0 and here 2. And put it in f dash x, that is 2 into x minus 1. If you put 0, 2 is positive, 0 minus 1 is negative. So f dash is negative. In the derivative, if you put 2, 2 is positive, 2 minus 1 is positive. So f dash is positive. Wherever f dash is negative, there f is decreasing. Wherever f dash is positive, there f is increasing. So you can see and write f is increasing on the interval 1 to infinity. But 1 to infinity, you can see it is in option D. So you will go for option D. Next, we will go to question number 31. F of x be a quadratic expression which is positive for all real x. G of x is f of x plus f dash x plus f double dash x. Then for any real x. What is happening? Look at the options. So first we will take f of x as a quadratic expression, ax squared plus bx plus c. And we will take a is greater than 0. So because the function is positive for all real x, we can say b square minus 4ac will be less than 0. So because g of x is given as f of x plus f dash x plus f double dash x. F of x is ax squared plus bx plus c. F dash x is 2ax plus b. And f double dash x is 2a. So taking a common, we will have x squared plus b by a into x plus c by a plus 2x plus b by a plus 2. Or we can write a into x squared plus, we'll take these two x terms, denominator is a, and then we have b minus 2a into x. Or b plus 2a into x. Then taking the constant terms, denominator is a, c plus b plus 2a. This is what we have. Now I will take these two terms and square it. I'll make a perfect square. So I'll simplify this g of x. In the next page, I will write g of x equal to this entire thing and simplify. How? A into a square plus 2 into A into B. B plus 2A by 2. So what I need is B plus 2A by 2A whole square I will add, and B plus 2A by 2A whole square I will subtract. And then I have C plus B plus 2A by B. So looking at this, I can write A plus B whole square. A plus B whole square. And then left is minus B plus 2A whole square by 4A square plus C plus B plus 2A by B. Or I can write A into X plus B by 2A plus 1 whole square. Plus denominator 4A square. So I have to multiply 4A. 4AC plus 4AB plus 8A square minus B square minus 4AB minus 4A square. 4AB and minus 4AB will cancel. Left is A into X plus B by 2A plus 1 whole square plus 4AC minus B square by 4A square plus 4A square by 4A square, which is 1. So A is positive, this term is positive because B square minus 4AC, B square minus 4AC is less than 0. 4AC minus B square will be greater than 0. So here positive, and 1 is also positive. All are positive, that means G of X will be positive. So if you come to the options, you will take option B, G of X is positive. Next, moving on to question number 32. Let f and g be increasing and decreasing functions from 0 to infinity to 0 to infinity. H of x is f of g of x. H of 0 is 0. H of x minus h of 1. That is what we have. Because we have to find h of x minus h of 1, let us take this as phi of x. When you find the derivative of phi of x, you have h dash x. What is h dash x? F of g of x derivative. That means you have to use chain rule, outer function, inner function. Derivative of f is f dash of g of x into inner function g, derivative is g dash of x. Now, we know that f is increasing, f dash will be positive. We know g is decreasing, g dash will be negative. So this f dash is positive, g dash is negative. So on the whole, phi dash of x is negative. That means phi of x is decreasing function. So if you take x greater than or equal to 0, phi of x will be lesser than phi of 0. Phi of x, that means h of x minus h of 1 is lesser than phi of 0. What is phi of 0? H of 0 minus h of 1. Removing minus h of 1 on both the sides, we have h of x minus h of 0. Lesser than 0. Or we can write it in a different way also. What's that? H of x minus h of 1 is lesser than h of 0 minus h of 1. But h of 0 is 0. So h of x minus h of 1 is lesser than minus h of 1. Which is present in option A. H of x minus h of 1 is lesser than minus h of 1. That is what we got it. Okay, next question number 33. Dash x is given as g of x into x minus a whole square. G of a is not 0 and is continuous at x equal to a. Then which option will be correct? We know that g is continuous at x equal to a. Now there are two possibilities in the option. G of a is greater than 0 or G of a is lesser than 0. Suppose if we take G of a greater than 0. Then what is happening? In f dash x, we have g of x and x minus a whole square. G of x is positive, x minus a whole square is positive. So on the whole, f dash x is positive. And f dash x is positive means what? f is increasing at x equal to k. So option B is correct. Option B. I'll put question number 30. What about f of x, that is x by 1 plus mod of x? Is it increasing or decreasing? So first we will take f of x as x by 1 plus mod of x. And we will find the derivative using quotient rule. Derivative of x is 1 into 1 plus mod of x. Then minus x into derivative of 1 plus mod of x. That is plus or minus 1. By 1 plus mod of x whole square. So f dash x in the numerator will be 1 plus mod of x plus or minus x. Minus is there. So minus mod of x by 1 plus mod of x whole square. So f dash x is left as 1 by 1 plus mod of x whole square, which is obviously greater than 0. So f is strictly increasing. Option A. Next is question number 35. F of x is log x by x plus log of 51. So take the function log of x by x plus log of 51. Find the derivative using quotient. Log x derivative is 1 by x into x minus log x into x derivative is 1 by x squared. One minus log of x by x. Make it equal to 0. 1 minus log x equal to 0. Log x equal to 1, x equal to k. On the number line, take the turning point x equal to k from minus infinity to plus infinity. Randomly take some numbers in each interval. Here you can take 2 and here you can take 3 and put it in f dash. F dash x is 1 minus log x by x squared. X squared is anyhow positive. When you put 2, f dash of 2, you have to find log of 2. Which will be less than 1. You know why? Log of E is 1. E means 2.7. E is 2.7. So if you take less than E, if you take 2, it will be lesser than 1. Lesser than 1 means what? 1 minus lesser than 1. So you have a positive answer. That means f dash is positive. Similarly, you put 3. If you put log 3, it will be greater than 1. Greater than 1 means f dash will be negative. So positive, but here negative. So f is increasing and then decreasing. So the increasing interval, increasing is for x less than e, and decreasing is for x greater than e. That is happening in option B. So option B can be as the correct answer. Next, we will go to question number 36. F is differentiable. F of 1 is minus 2. F dash of x is greater than or equal to 2 for all x in the interval 1 to 6. So here you will be using MVT, Lagrange's mean value theorem. So if you take the interval 1 to 6, f is differentiable, that means it is continuous also. Now f of 1 is given as minus 2. So according to mean value theorem, f dash of c will be f of 6 minus f of 1 by 6 minus 1. F of 6 is not given, but f of 1 is minus 2, so plus 2 by 1. Because it is f of f dash is greater than or equal to 2. F of 6 plus 2 is greater than or equal to 10. F of 6 is greater than or equal to 10 minus 2, that is 8. So option A is the correct option. Next is question number 37. The function tan x for x not equal to plus or minus pi by 2 and plus or minus 3 pi by 2. What type of function is it? So we will take f of x equal to tan x. F dash x is secant square x. We'll make it CET. Actually, secant will never become CET. Secant square will never become CET. And we know that secant square x is greater than 0, positive. That means f dash x is greater than 0. That means f is ever increasing. Option A is the correct answer. This is question number 38. The function f of x equal to x by 1 plus x minus log of 1 plus x. For x greater than c, increasing, decreasing, you have to find. F of x is x by 1 plus x minus log of 1 plus x. So derivative, you will use quotient rule. Derivative of x into 1 plus x minus x into derivative of 1 plus x by 1 plus x whole square minus, for log you will use chain rule. Log of x derivative is 1 by 1 plus x, but derivative of 1 plus x is 4. Or I can write f dash x is 1 plus x minus x by 1 plus x whole square minus 1 by 1 plus x. Denominator 1 plus x whole square. X and minus x will cancel. 1 minus 1 plus x. So 1 minus 1 minus x by 1 plus x whole square. 1 and minus 1 will cancel. So we have f dash x equal to minus x by 1 plus x whole square. Because x is greater than 0, minus x will be lesser than 0. So we got f dash lesser than 0. That means f is decreasing. F of x always decreases. So option B is correct. Next, question number 39. I'll put options also. Only one option I have written here. The other options also. According to the question, the function is cos x into sin 2x. You have to find minimum. So because the function is cos x into sin 2x, to find the derivative, we have to use product. Derivative of cos x is minus sin x, sin 2x plus cos x say using chain rule, derivative of sin x is cos x into derivative of 2x is 2. That means we have minus sin x, sin 2x is 2 sin x cos x plus 2 cos x cos 2x is 2 cos square x minus 1. Or we can write minus 2 sin square x cos x plus, we can multiply 4 cos cube x minus 2 cos x. So sin square x, I can write 1 minus cos square x into cos x plus 4 cos cube x minus 2 cos x minus 2 cos x plus 2 cos cube x plus 4 cos cube x minus 2 cos x. So 6 cos cube x minus 4 cos x. You can take 2 common and cos x common. 3 cos square x minus 2. Suppose this f dash of t, we will take it as f dash of x. If we take it as g of t, this is f dash of x. So 6t cube minus 4t. I will write 6t cube minus 4t. Now this g dash t will be 18t square minus 4. Set it equal to 0. T square is 2 by 9. I don't think in this method you will get the answer easy. So we'll do one thing. We will use a different method. I'll put the question again. Because this method is becoming more complicated and complicated. So I'll find an easy method. First of all, the function cos x into sin 2x we will simplify. Sin 2x I will write 2 sin x cos x. So the function becomes 2 sin x into cos square x. Now cos square x I will write as 1 minus sin square x. So it is 2 sin x minus 2 sin cube x. So we will write this function as g of t and take the minimum. 2t minus 2t cubed. Like this we will change it so that it will be easy. G dash t will be 2 minus 6t square. You will set it equal to c. 6t square is 2. T square is 1 by 3. T is plus or minus 1 by root 3. This is the turning point. Now, because g dash t is 2 minus 6t square, g double dash t will be minus 12t. When you put t as 1 by root 3 in g dash and minus 1 by root 3 in g dash, g dash of 1 by root 3, g double dash of 1 by root 3, we will get negative. G double dash of minus 1 by root 3, we will get positive. Negative means G is concave down. Positive means G is concave up. So here we have maximum and here we have minimum. So minimum of G of t is at t equal to minus 1 by root 3. Because G of t is 2t minus 2t cubed. G of t is 2t minus 2t cubed. G of minus 1 by root 3 will be minus 2 by root 3, then plus 2 by 3 root 3. So which is minus 6 plus 2 by 3 root 3, which is minus 4 by 3 root 3. What is this minus 4 by 3 root 3? It's not option A. So we have to go for option B only. Because it is greater than minus 9 by 7 or minus 7 by 9. If you want, you can use calculator and see. Okay. So we can go to question number 40 now. If y is a log x plus bx square plus x has extremum value at x equal to minus 1 and 2. So you are taking y as a log x plus bx square plus x. Y dash will be a by x plus 2bx plus 1. So when you set equal to 0, you will get x equal to -1 and x equal to 2. You put x equal to -1. So minus a minus 2b plus 1 is c. Put x equal to 2. A by 2 plus 4b plus 1 equal to 0. Or a plus 8b plus 2 equal to 0. Now we have two equations. A plus 2b minus 1 equal to 0. The first one. And a plus 8b plus 2 equal to 0. You can put any of the options and check. Suppose if you take the A option. A is 2, B is -1. -2, -1. You are not getting 0. So option A is not correct. Option B, A is 2, B is -1 by 2. So -1, -1. Here you are getting 0. That means option B is correct. If you want, you can check the other one also. A is 2, B is -half, so -4 plus 2. Here also you are getting 0. In both the equations, I have checked. Now we will go to 41. The maximum value of log of x by x in the interval 2 to b. Take y equal to log of x by x. Find y dash using quotient rule. Log x derivative is 1 by x into x minus log x into derivative of x is 1 by x squared. So it's 1 minus log x by x squared. Set it equal to 0. 1 minus log x is 0, log x is 1, or x is e. So obviously without any verification, you can say here you will have maximum. But you have to find maximum value. Log of e by e. Put x equal to e in y. So 1 by e is the maximum value. Option D. Next. 42. The function is x power 1 by x, has maximum value at x equal to e. Then what we have to prove? That is what you are going to say. So f of x is given as x power 1 by x. And we know x is greater than 0. X equal to e is the maximum point. That means all f of x will be less than f of e. F of x means what? X, you have to take some number. Why not take x as pi? F of pi will be less than f of e. So f of pi means pi power 1 by pi. And f of e means e power 1 by e. Now, both the sides, in order to get the options, take the power as pi e, the common denominator, both the sides. Then you will have pi power e is less than e power pi. That is option A. Next is 43. We can do this as the last question. F of x is x plus 4 by x, local maxima and local minima. So f of x is x plus 4 by x. F dash x is 1 minus 4 by x square, set it equal to 0. 4 by x square equal to 1, x square is 4, x is plus or minus 2. Find f double dash x. So 8 by x cube. F double dash x is 8 by x cube. In this, when you put plus 2 in second derivative, you'll get a positive answer. When you put minus 2, you will get a negative answer. Positive answer means the function is concave up, and then the function will have minimum. Negative answer means the function is concave down, and then there will be maximum. So minimum is x equal to 2, maximum is x is minus 2. So which option? Option B. Holds good. So with this, we can end the class. See you in the next class, and we'll do more problems in the next class.